Let's talk about numbers. For today's lesson, we will discuss rational functions, equations, and inequalities. We have here the learning competencies. The learner distinguishes rational function, rational equation, and rational inequality. The learner will solve rational equations. First, we have the definition of terms. We have here the definition of a polynomial. A polynomial function p of degree n is a function that can be written in the form of this one. So again, a polynomial, we can write polynomial of p of the or polynomial function p of the degree n as this equation, where a sub 0, a sub 1 to a sub n is an element of a real number, and a sub n should not be equal to 0, and n is a positive integer. Each sum none is a term of the polynomial function. The constant a sub 0 to a sub n are the coefficients, and the leading coefficient is a sub n. The leading term is a sub n x to the n, and the constant term is a sub 0. Next, we have the definition of a rational expression. A rational expression is an expression that can be written as a ratio of two polynomials. So again, if you already know the definition of a polynomial function, then you can also determine what is a rational expression. Again, a rational expression is an expression that can be written as a ratio of two polynomials. Next, we have a rational function. A rational function is a function of the form f of x is equals to p of x all over q of x, where p of x and q of x are polynomial functions, and q of x is not the zero function. That is, q of x should not be equal to 0. Since the moment q of x is equal to 0, then our given function is undefined. The domain of f of x is all values of x, where q of x is not equal to 0. So we have here the illustration to further understand what is rational function, rational inequality, and rational equation. Rational equation. We have here the definition. So an equation involving rational expression. So again, rational equation is an equation involving rational expression. And again, if we talk about rational expression, it is an expression that can be written as a ratio of two polynomial. So here we have an example. This is an example of a rational expression, a rational equation rather. 2 over x minus 3 all over 2x is equals to 1 over 5. So here, 2 over x minus 3 over 2x is equals to 5 is a rational equation since the given expression is separated by equal sign, and also the numerator, which is 2, 3, and 1 are rational, are polynomial. In this case, 1, 2, and 3 are the constant function. And x, 2x, and 5 are also polynomials. So therefore, this is rational equation. The next is we have the definition of rational inequality. An inequality involving rational expression. So the difference between rational equation and rational inequality is that rational equation is separated by equal sign, but rational inequality is separated by an inequality sign. So we have greater than, the less than, the greater than or equal to, and the less than or equal to. So these are the inequality signs. So the moment it is an irrational expression and is separated by an inequality sign, then this will be a rational inequality. The next we have rational function. Rational function, a function of the form of, again, the definition is f of x is equals to p of x all over q of x, where p of q and p of x rather and q of x are polynomials, and q of x is not the zero function. So again, the denominator should not be equal to 0. So again, we can represent a rational expression by f of x or by y, provided the denominator and the numerator of the given function are polynomials. So here we have an example of rational function, rational equation, and rational inequalities. So the given instruction is determine whether the given is a rational function, rational equation, rational inequality, or none of these. So we have number 1. Y is equals to 5x cubed minus 2x plus 1. So this is a rational function since the given are polynomials. So again, this is rational function since the given are polynomial. And the denominator of this function is 1. So therefore, this is a rational function. Number 2, we have 5x cubed minus 2x plus 1. Is 5x cubed minus 2x plus 1 is equal to 0. So this is a rational equation. So again, why rational equation? Since the given expression is a polynomial and the denominator is 1. However, it is separated by equal sign and it is not a function since it is not represented as f of x or as y. So therefore, this is a rational equation. So next is we have 5x cubed all over 2x plus 1 is equals to 0. So again, since this is separated by equal sign, and the denominator, which is 2x plus 1, and the numerator are polynomials, so therefore this is rational equation. So next, number 4, we have 4x squared plus 7 all over 2x plus 1 less than 0. So this is a rational inequality since it is separated by inequality sign less than, and the numerator and the denominator of the given expression are polynomials. So next we have 2x squared minus 7 all over 2x is equal to 0. So this is a rational equation since again, it is separated by equal sign and the numerator and the denominator are polynomials. Next, we have number 6. F of x is equals to the square root of x plus 2 all over 2x. So again, this one is none of the following. It is not rational function, it is not rational equation, it is not rational inequality. Why? Because the numerator, which is this one, square root of x plus 2, is not a polynomial. If we talk about a polynomial, the exponent of x should be positive integer. The square root of x plus 2 can be written as x plus 2 to the 1 half, which is 1 half is not an integer. So therefore, this is not a rational function, rational equation, and rational inequality. Next, we have number 7. X squared plus 4x all over 2x to the 3 over 4 plus 1 is equals to 0. And this is not none of the following, since again, the denominator, which is 2x to the 3 plus 1 is not a polynomial, since 2x to the 3, I mean 3, the exponent of x, which is 3 is not an integer. So therefore, this is not a polynomial. Since this is not a polynomial, so therefore, it is not a rational function, nor rational equation, nor rational inequality. And number 8, we have x squared plus 7 all over the square root of x plus 3 greater than 0. So here, again, this is not a it is the given denominator, which is the square root of x plus 3 is not a polynomial. So therefore, the given expression are not rational function, not rational equation, not rational inequality. So therefore, this is none of the given choices. So again, here, as you observe, even though it is separated by equal sign or an inequality sign like this one, separated by equal sign, it does not always follow that the given equation is a rational equation. Then, even though it is separated by equal sign and it is represented by f of x, which is this one, it does not always guarantee that the given function is a rational function. Okay? Then lastly, if it is separated by inequality sign like this one, it is not always guaranteed that the given inequality is a rational inequality. So again, we need first to verify if the numerator and the denominator of the given expression are polynomial. If one of the conditions are not met, therefore it is not a rational function, rational equation, and rational inequality. So next, we have this one. How to solve rational equations. So we have here the step. Number 1 is to eliminate the denominators by multiplying each term of the equation by the least common denominator or the LCD. Then second is simplify the equation to get the value of the variable. So we have here an example. So find the solutions or a solution for the rational equation below. We have number 1, 3 over x plus 1 is equals to 2 all over x minus 1. So we have the solutions. So the LCD for this equation are x plus 1 times x minus 1. So again, the least common denominator is x plus 1 times x minus 1. The next, we have this one. So again, when we'll multiply this, we will distribute this to our original equation. So we have 3, the quantity 3 all over x plus 1 is equals to 2 all over x plus 1 times the given LCD, which is x plus 1 times x minus 1. So next, we have this one. So we will distribute already. So 3 times x, again 3 times x plus 1 times x minus 1. Then we have 2 times x plus 1, then x minus 1. So then we will copy the denominator since the denominator of the LCD here is 1. So 1 times x plus 1 is just x plus 1. And 1 times x minus 1 is just x minus 1. So next, we have, since x plus 1 is since we have x plus 1 in the numerator and we also have x plus 1 in the denominator, and it is separated by a multiplication, then we can cancel x plus 1. X plus 1 all over x plus 1 is just 1. Same as 2 over 2 is 1, or 3 over 3 is 1. So same with this one. So we can cancel x minus 1 all over x minus 1 on the numerator and on the denominator. Since again, x minus 1 all over x minus 1 is just 1, or same as 3 over 3 is just 1. So we have the given equation. 3 times x minus 1 and 2 times x minus 1. So distribute 3, or we will use the distributive property, and distribute also 2. So we have the given equation. So 3 times x, that is 3x. 3 times negative 1, that is negative 3. 2 times x, that is 2x. And 2 times 1 is 2. So we have this one. So next is, we will add or subtract similar terms. So 3 minus 3, 3x minus 3 is equal to 2x plus 2. So using the additive inverse of 2x, or what we call that, the transposition, okay, we will have, so just copy 3x minus 3 minus 2x. Why 2x? Since we transfer 2x from this side to this, or what we call that, we use the additive inverse of 2x. So if we add both sides by negative 2x, so obviously this side will be 0, and we have here negative 2x. And again, so with number 2. So we have, so again, transposition or additive inverse, same. So we have 3x minus 3 minus 2x minus 2. So again, why negative? We use the additive inverse or by transposition. So again, 3x and negative 2x are similar terms, so we can add them. So therefore, we have 3x minus 2x is x, and 3 minus 2, I mean negative 3 minus 2, that is negative 5. So we will add them, since negative 3 minus 2 is equal to negative 5. So we have x is equals to 5. Why 5? Since if we transfer negative 5 to this side, the negative 1 will become positive. That is by transposition or by additive inverse. So therefore, the solution for this one is x is equals to positive 5. So next, we have here the alternative solution for number 1. So we have same equation, 3 all over x plus 1, which is equals to 2 all over x minus 1. But this one, we will use the alternative solution. So we have here the solutions. Again, copy the original equation. 3 over x plus 1 is equals to 2 over x minus 1. So here, we can use cross multiplication. So we can multiply. We will not find the LCD. So, but instead, we will use the cross multiplication. So we have 3. So we have this one, 3 times this one. So we have 3 times x minus 1, then 2, which is this one, times x plus 1. We have 2 times x plus 1. So we have distribute 3. So we have 3x minus 3 is equals to 2x plus 2, since 2 times x is 2x and 2 times 1 is 2. Then again, using the transposition, we have, or the additive inverse, we have 3x minus 3 minus 2x minus 2 is equal to 0. So next, we have x minus 5. So again, y, the yellow part, we have 3x minus 2x is equals to x or 1x. So since it is just 1, so we will write x. Then negative 3 minus 2, that is negative 5, and that is equal to 0. So next, using the transposition or the additive inverse again, we have x is equals to 5. So if we transfer from this side to there, then we will have from negative to positive. Okay? So the final answer will be x minus 5. So if you observe, number 1 and number 2 yield the same answer, and we use different techniques in solving. Okay? So again, in mathematics, we can use any any solution, but again, we will yield the same answer if you do it right. So next, example number 3. 2x all over x plus 2 plus 5 all over 2x is equals to 2. So again, we need to find the solution. We have the solutions. So the LCD for this one is x plus 2 and times 2x. And the denominator of 2 is just 1. So again, we will not write 1 here as an LCD. So again, x plus 2 times 2x. Then copy the equation, which is this one. The original equation, we copy the original equation, which is this one. Then multiply by the LCD, which is x plus 2 times 2. So we have, so again, distribute the LCD to the given expression or to the given equation. So we have this one. So this is the green one. So the green one. So the green one arrow yield 2x. So why 2x? We have 2x. We just copied this one, 2x. And times x plus 2 times 2x. So we copy this one. And again, we don't forget to write the open and close parentheses for this one, for this, so that we can determine that it is separated by a multiplication. The next, for the red one arrow, we yield as 5. We just copy 5, then we also copy that x plus 2, then 2x. Then the last one, which is the blue one, we yield, the result is 2 times x plus 2 times 2x. Then we copy the denominator, which is x plus 2 and 2. So we have already the equation. Now, we can cancel some expression here. So we can cancel for this one, x plus 2 all over x plus 2. Why? Again, x plus 2 all over x plus 2 is just 1, or sabi ko nga is 4 over 4 or 2 over 2 is just 1. So we can cancel x plus 2 all over x plus 2. In this side, we can cancel 2x and all over 2x. So we have, so again, we have, since we already cancel x plus 2 over x plus 2, we have 2x times 2x. And for this side, we have 5 times the quantity x plus 2. And for the last part, is equals to, we just copy 2 times x plus 2 times x, 2 times x plus 2 times 2x. And we have here, so 2x times 2x is 4x squared. So again, the exponent of x here is 1. So therefore, we add the exponent, that is 1 plus 1, that is 2. So 2 times 2 is 4. Then the exponent of x is 1. So 1 plus 1 is 2. Therefore, we yield 4x squared. The next, distribute 5 to the given expression. So that is x plus 2. So 5 times x is just 5. And then 5 times positive 2, that is positive 10. So therefore, we have plus 10. Then here, we will distribute 2. Okay? So we will distribute 2. So 2 times x, that is 2x. Then 2 times positive 2, that is 4. Then copy 2x. So again, we only distribute 2 to x plus 2. We didn't distribute yet 2x. So we just copy 2x. Next, we have this one. So we just copy. So we just copy the entire expression, which is this one, right? So we have here 4x squared plus 5x plus 10 equals, here we will distribute already the 2x. So we will distribute the 2x. So that is 2x times 2x, that is 4x squared. Then 4 times 2x, that is 8x. So therefore, we have this expression, that is 4x squared plus 5x plus 10 is equals to 4x squared plus 8x. Next, we have here, so we highlighted similar terms. 4x squared and 4x squared are similar terms. 5x and 8x are similar terms, and we have the constant one, that is 10. So we have this one. So 4x squared minus 4x squared. Why 4x? Why negative 4x? It's 4x squared. Since we use the transposition rule, or we use the additive inverse. So we transfer from right side to left side. Therefore, we have from positive 4x squared, we have negative 4x squared. Then from positive 8x, we have negative 8x. So we have 4x squared minus 4x squared. And we have 5x, just copy 5x minus, again from positive, we will, the positive 8x, we will have negative 8x by transposition or additive inverse, then plus, then just copy 10. So we have here 10. So we can, n equals to 0. Since all the expression here are transferred from this side to here, so obviously, the remaining number here will be 0. Okay? So therefore, we will write 4x squared minus 4x squared plus 5x minus 8x plus 10 is equals to 0. So 4x squared minus 4x squared, obviously that is 0. So we will not write 0. So again, this is 0. So therefore, we will not write here 0. So this will imply, so then 5x minus 8x is equals to negative 3x. So 5x minus 8x is negative 3x. Since negative 8x, the coefficient of negative is bigger than the positive one. So we will carry the negative sign. So that is negative 3x plus 10. We just copy 10. Since 10, we don't have any similar term with 10 or with the constant term. So negative 3x plus 10 is equals to 0. So by transposition again, or by additive inverse, from positive 10, we will have negative 10. So therefore, copy negative 3x is equals to negative 10. So divided by, so again, simplify, we have negative 3x all over negative 3 is equals to negative 10 all over negative 3. So again, we divide it both sides by negative 3. So here, we have here, so we cancel negative 3 in this side. So we have the final answer, we have x equals to 10 all over 3. Why 10 all over 3? Since negative divided by negative is positive. That is the rule in dividing or multiplying. Negative times negative is positive. Negative divided by negative is positive. Okay? So next, we have here a practice exercise. So you need to practice. So first, we have determined whether the given is a rational function, rational equation, rational inequality, or none of these. So we have here the different expression. So next, we have here find the solutions or solution for a rational equation below. We have 5 all over 2x plus 1 is equals to 2. Then 2, number 2, 2 or all over 2x plus 1 is equals to 3 all over x minus 4. And last one, 5 all over x plus 1 plus 6 over x minus 1 is equal to 7. So this will be for your practice or exercise. So again, for letter A, you only need to determine if it's a rational function, rational equation, rational inequality, or none of these. Then for letter B, you need to find the solution or you need to find the value of the variable x. So again, thank you very much. So again, don't forget to subscribe this channel for more video content.